Okay, here's another video I'm making with my iPad. You guys know I'm not great at writing on my iPad, so bear with me, but I wanted to be able to help you out with this concept. We're going to be looking at some ratios, but on a coordinate graph. So we're going to start off with a pretty easy one here. If you'd like to put this in your notes, you can. If you want to just follow along with this first one, I'd say this is really more of a thought exercise to make sure we're interpreting things correctly when we're reading it, and we're getting the idea of comparing parts versus comparing parts to whole. So we're given 2 points. Notice that the points have the same y-coordinates. They both have a y-coordinate of 3. So that's telling me that I have 2 points that are lined up horizontally on a coordinate graph. So I'm going to do a quick sketch here. It's not going to be the entire coordinate graph because I don't need the entire coordinate graph. So all I'm going to do is try to draw the y-axis, the x-axis here, and then I'm going to plot those 2 points, 0, 3. Let's just put that right here. And then 23. Let's make this 20 out there. And 23 right there. So here's point A. Obviously, it would help if I put some letters on here. Here's point B over here, 23. And then I guess I should use a different color for that segment. Let's go ahead and do that. In green, we'll do the segment AB. So I've got AB is green. C is the midpoint of AB. So if C is the midpoint of AB, then it's going to be sitting right at 10, 3. So there's point C. And then D is the midpoint of BC. So then D is going to be right here, and I'm sure you're doing the mental math also that that's going to be at 15, 3. So I don't really need those coordinate points other than to know those x values. And from here I'm going to turn it all into lengths. So the first question I'm asking is, what is the ratio of AD to DB? So AD to DB, well, it looks like AD is that, and DB is the other part. I guess that's what I've got left. Let's do it in yellow over here. That end part. So AD, it looks like, is all the way from 0 to point D, which was 15. And then DB is the last part, which is 5. So I'm just going to use numbers to represent those lengths, since it's horizontal on my coordinate graph and I can count them. So 15 to 5. And I can write a ratio with a colon in the middle, write it with the word 2. 15 to 5, that reduces to 3 to 1. So I always like to look at ratios in reduced form. What does this mean? Well, this means that AD is 3 times as long as DB. So when I'm comparing those 2 parts of that entire segment there, AD is 3 times as long as DB is. Now, that wasn't supposed to be a hard question. Things are going to change as we move throughout this. So just keep that thought in mind of what we're comparing there. Could D be in any other point such that it divides AB into 2 parts with the same ratio? So could we create a ratio of 3 to 1 on that segment, but D is actually in a different spot? So we would still have to have the 2 lengths of 15 and 5, but if you're not worried about the order, because with the ratio it doesn't matter what order it's in, then we could obviously put D on the other side. So we should be seeing that D could be right over here. I know you wanted me to put that 5 in there. And then AD would be the smaller length, and that would be 5, and then DB would be the length of 15. So it could be at the point 5, 3 if we're going to use the ordered pair there. And then we have that ratio of 5 to 15, which is 1 to 3. Same thing in the world of ratios, unless I specify which part has to come first. So we have 2 spots along there. Keep that in mind. What is the ratio of AD to AB? Okay, so I'm going back to A, and I'm slightly changing the question, and instead of asking about AD to DB, I'm going to ask AD to AB. Recall AB is this entire length here. So, turns out the first part isn't changing. AD is still length of 15. AB is the entire thing, and we said that that was the first thing I drew in there. That was 20. So my ratio is no longer 3 to 1. My ratio is now a ratio of 3 to 4. What does that mean? Well, that means that AD is 3/4 the entire length of our starting segment AB. So now we're comparing the part to the whole length. And there's a difference there, because I'm really using, I never had a part of 4 when I was talking here. I had a ratio of 3 to 1. 4 is, notice if you add those two parts, because I had the 3 and then the 1. So now I'm comparing the 3 to the 4. And what's the ratio of BD to AB? Last question. So BD to AB, well, that's the other part compared to the whole. So it would make sense that if I have 3 to 4 here, and it's 3/4 of the entire length, then AB is going to be 1/4 of the entire length. So if we're talking about parts, it's 5 compared to my entire length of 20. And that ends up being a 1 to 4 ratio, or it's 1/4 of the entire. So we're going to take that same concept. That was your warm-up. And that's because we were going on a horizontal line. Things are always nice when we can count them on the coordinate graph. And let's go ahead and look at what if our segment is not. So essentially my question is, what if my segment is not horizontal? What if it's at some slant? So we've got this segment right here. It's obviously at a slant on my coordinate graph. And my question is, use similar triangles to find point P that partitions a given segment into a 4 to 1 ratio. Okay, so this one I'm implying that we want to do parts. 4 to 1, I want one part to be, so it's not going to be 1 is the part and 4 is the whole. I want 4 to be one of the parts and 1 to be the other, comparatively speaking. So you could say that the one part is going to be 4 times as long as the other, going back to what we said in part A for interpretation. And then we're going to use distance formula to verify that the lengths are in the ratio of 4 to 1. We just counted last time. We didn't have to. We could have used distance formula, but not necessary when we're horizontal on a coordinate plane. So the first thing I'm going to do is I'm going to sort of take a guess, because I can do that. So 4 to 1, I'm going to start in my top left. Let's go ahead and just put some letters here, and we'll call this A, and we'll call this B down here. And let's see, A has coordinates of -7, +4. And B has coordinates of 3, -1. I'll need that later for distance formula, if nothing else. And like I said, I'm going to go ahead and take a guess, and then C, I want it to be in the ratio of 4 to 1. And that means the one part is to be 4 times as big. That's going to be a lot longer. So I'm going way past half here, and I'm going to go down here. It looks to me like it crosses right here. I'm taking a guess. And I'm going to say that it looks, I'm trying to find a nice point too. It might not be a nice point where my coordinate graph crosses. It doesn't have to be in integer values, but I'm going to guess that it's that point right there. So how am I going to check this? Well, I'm going to go ahead and draw in the two triangles that are created here. And I'm going to do that by saying that I go down to get to that point. Whoops, not quite that far. Let's try that again. Down just to my origin, which takes me down 4. And then I'm going to go over horizontally. And I'm going to go ahead and count that. 1, 2, 3, 4, 5, 6, 7, 8. units to get over to there. So I went down 4 and over 8. Now let me do that again for this little triangle. I went down 1 and I'm going to go over 2. So here's the deal. I can't measure things on the diagonal, but what I want is I want for this part to be 4 times as long as this part. So they don't really have to be a length of 4 and a length of 1, but they have to reduce to that ratio. So in other words, it could be 8 and 2, it could be 12 and 3, it could be any number of things that reduce to 4 to 1. So I might be better off saying that that's 4x and this is 1x, or whatever you want to use to represent that unknown length. But the whole point is that if we look at those two triangles that I just created, if these two triangles are similar, and if they have a ratio of 4 to 1, then the ratio of these two sides is going to have to be 4 to 1. So first let's convince ourselves that those two triangles are similar. And my proof here is I've got a right angle there and there. So that's one pair of angles congruent. And then if we can agree that horizontal lines on a coordinate graph are parallel, or vertical lines are parallel, either way we've got corresponding angles, or we've got corresponding angles there and there. So by angle, the triangles are similar. Once I have that established, then I can look at the ratio of the corresponding sides. So if I'm going to go ahead and look at ratios here, I've got 4 over 1 if I'm comparing the verticals, and then I've got 8 over 2 if I'm comparing the horizontal lengths to each other. So the other lengths that I haven't said, so let's just call this point for a second. I'm going to call that point P, since they said call it point P. AP over PB is going to have to equal the same ratio, because by definition of similar triangles, and I just established they're similar by angle-angle similarity, definition of similar triangles tells me all sides have to be in the same ratio. So we can see that obviously that reduces to 4 to 1, and my reduced ratio is going to be 4 to 1. So sort of by guess and check, I was able to get that point, or you could say counting slope. I've seen people do the problem this way, where they kind of work out and map out every slope. So they go down 1 over 2, down 1 over 2. Oops, I'm off. Let's try that again. Okay, same concept. Down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. And they say, okay, I did it 5 times. Well, I need a ratio of 4 to 1, but altogether that's 5 parts I need. Group 4 of them together, and that takes you from A to P, and then group the other, well, the last one is going to be your remaining 1 part. So that's one possible spot for P. Let's go ahead and verify that with the distance formula. So, because we should be able to see what these lengths actually come out to be, AP and PB. So let's go ahead and use the distance formula here. And I'm going to start with the length of, let's see, we can do the length of AP. So coordinates of P, it looks like, are 1, 0. Is my guess. So AP is square root of 1 minus a negative 7, so that'd be plus 7 squared, plus 0 minus 4 squared, that'd be 8 squared, plus a negative 4 squared, which is 16. So I've really got 64 plus 16 is the square root of 80. And that's 16 times 5, so that'd be 4 radical 5, if I'm simplifying it. No, come on. Doesn't want right on the very edge. So I've got 4 radical 5 for the length of AP. go ahead and do the length of PB. So PB is square root of 3 minus 1 plus negative 1 minus 0. That gives me 2 squared, which is 4, plus negative 1 squared, which is 1, is the square root of 5. And there we have it. We've got our ratio of our actual lengths. Square root of 5s cancel out. And I'm getting a ratio of 4 to 1, just like I had here and here. So that's some nice verification for you, that it actually does work out. Remember, I said that these lengths aren't really just 4. It's 4 times something and 1 times something. Turns out that something is radical 5. We're just using 4 to 1 to represent that. And the last question there is there another possible location of point P? So hopefully you're seeing that it doesn't matter that I started at A. I could have started at B, and if I kind of counted my slope or reversed those triangles, the other possible answer should be this point up here. Could be my P, and that would be the coordinates negative 5, positive 3. So 1, 0, or negative 5, positive 3 would be my locations for P. That gives you a really good introduction to this concept. The only question I'm going to pose, and I'm going to put this in a different video because I want to make sure that it uploads okay. The only question I'm going to pose is what happens if P is not at a countable point? What if it's not integer values? Because that could happen. And this is where we're going to use similar triangles to actually solve for the length. I sort of did guess and check and verified. But I'm going to turn it into a familiar problem and actually take it off the coordinate graph to help me out. So join me in my next video and we can tackle that question.